Hi, I'm going to give you some information on how you can solve quadratic and absolute value inequalities graphically. This pertains to section 11.8 and section 9.2 in your textbook. The first thing that I want to kind of review to you about how to do this is some things that you need to know about the graph. First of all is that the solutions to an equation of the form f of x equals 0 are the points where the graph crosses the x-axis. So the solutions to f of x equals 0 are the points where the graph crosses the x-axis. In other words, these are just the x-intercepts. Another fact to remember is that for values that are not solutions, f of x will either be greater than or less than 0. Now remember what f of x is. F of x is another name for y. So we're basically saying that if it's not a solution to the equation, the y value for that particular x value is either going to be larger than 0 or less than 0. If the point f of x, which can be written really xy, lies above the x-axis, then that means the y value, or the f of x value, is larger than 0. If the point f of x, again, xy, lies below the x-axis, then the y value is less than 0. And here I've stated again that remember f of x is simply the y value that corresponds to the given value of x. Here's what we can see graphically. So I've plotted a few points. We'll call these point A, which is at the point -2, 1. B is at the order pair 1, -2, and C is at the point 2, 0. Now, based on the plotted points, we know that f of 2 is equal to 0. That means that the y value, or f of x value, is 0 at x equals 2. We also know that f of 1 is equal to -2. That is, f of x, or the y value, is less than 0 at x equals 1. And f of -2 is equal to 1. That means that f of x is greater than 0 at x is equal to -2. So these are just talking about how the x and y values relate. If it's on the x-axis, then the y value is 0. Otherwise, it can either be above the x-axis or the point could be below the x-axis. So here I've given you another example of just a graph of a straight line, and just trying to get the idea of what does it look like for the points to have y values that are greater than 0 or y values to be less than 0. So really the very first thing that you have to do is to notice where is the y value 0. Well, the y value is 0 here at this x-intercept point. This happens to be the point 2, 0. So y is only equal to 0 at this value of x is equal to 2 because that's the only place where it crosses the x-axis. But to the right of this x equals 2, notice that all of the y values are lying above the x-axis, which means for every value to the right of 2, all those y values are larger than 0. Now to the left of 2, in this direction, all of the points are below the x-axis, which means all of these x values have y values that are less than 0 or are negative. So again, positive y values are going to be up above the x-axis, and negative y values are going to be below the x-axis. Here's another example of a parabola, similar like you would see in one of your homework problems from section 11.8. And what I've noticed is that there's, first of all, 2 points where it crosses the x-axis. These are your x-intercept points. And those happen to be at -1 and at 3. And so what happens then is that your graph is really subdivided into 3 parts. To the left of this -1 is going to be region A, so this is everything to the left of -1. in between the -1 and 3, and then the last region is to the right of 3. And notice what is interesting about these different regions. If I'm in region A, every point on the graph, in this particular case, has a y value that is positive. We know that y is greater than 0 in region A. Then in region B, all of those points lie below the x-axis, so that means those y values are negative. And in region C, notice that all of the points on the graph lie above the x-axis, so all of those y values are positive or greater than 0. So we know this, that since the graph lies above the x-axis in regions A and C, we said that f of x, or y, is greater than 0 from negative infinity to -1, and from 3 to infinity. So remember, these are just ways to indicate an infinite interval, all the values less than -1 and all the values greater than 3. So we answer with intervals of x that tell us what the y values are doing. Now we could also say that since the graph lies below the x-axis in region B, we say that f of x, or y, is less than 0 on the interval between the -1 and 3, and that's written in this notation, parentheses -1, comma 3. So let me give you some steps about how you're going to solve a quadratic inequality, and then we're going to use a graph to actually get the answer. Now, in your book, you were shown ways that you can test points from the regions after you find the x-intercepts. You could still do that, but this is an alternate way and actually could be done much quicker than using the test points. So to solve a quadratic inequality, you want to first find solutions to the equation. That is, you're going to replace the inequality with an equal sign and solve for x. And here you're going to have to use one of the methods, either the quadratic formula, or you could use factoring. All of these I think actually are factorable that you're going to see. If you don't like that, you could do completing the square or even the square root property. And then once you do that, you want to graph the equation, and then you're going to use the graph to determine the intervals that satisfy the given inequality. That is, if you want it to be greater than 0, you're going to choose the ones that are above the x-axis. Less than 0, you would choose the portion of the graph that's below the x-axis. So let's look at an example. We want to solve this problem that x squared minus 3x minus 10 is less than 0. So the very first step is we want to solve the associated equation. We replace the inequality with an equal sign and solve. Here notice that we find the factors of 10 whose difference is 3, and that is 5 and 2. The last sign being negative says our signs are different, and the middle one tells us the sign of the larger. So we know that we put the minus with the 5 and the plus with 2. And then solving by factoring, we just set x plus 2 equal to 0, which gives us x is equal to -2 by subtracting 2 from both sides. Or x minus 5 is equal to 0. We can add 5 to both sides to get that x is equal to 5. So the second thing we want to do is to graph the function y is equal to x squared minus 3x minus 10. And whenever we graph, I've imported the graph here. This confirms the solutions, right? We found that x equals -2 and x equals 5 were the solutions. Well, remember what those are. Those are really the x-intercepts of the graph. That is where the graph crosses the x-axis. And to the left of -2, notice that all the points are above the x-axis. Between the -2 and 5, that is region B, all the points are below. And then to the right of 5, that is region C, all the points in the graph were above. Now remember what we needed to solve. We needed to find the values that make x squared minus 3x minus 10 less than 0. Well, to be less than 0, what we're really saying there is we're trying to find where y is less than 0. But less than 0 means where the points are below the x-axis. And so if we examine, the only region that had points below the x-axis was this region, region B. That is between the -2 and 5. And so our answer then is going to be that interval from -2 to 5. Now, how else could you have done that? You could have tested points, a point from region A, something less than -2, so maybe like -3. You could have also tested a point from region B, something between -2 and 5, like 0. And then from region C, something to the right of 5, like 6. And remember there, you could plug into the original inequality and see which one would be true or false. And you should find that the only one that tests true is region B. Let's do another example. This time we want to solve x squared minus 4x plus 3 is greater than or equal to 0. So again, the very first thing we do is to solve the associated equation. Let me get this pen better. So we said where x squared minus 4x plus 3 is equal to 0, we again do this by factoring. The factors of 3, whose sum is 4, are 3 and 1. And we know that the signs are the same. And they are the same as whatever's in the middle, so they have to both be negative. So then we set x minus 3 equal to 0, or x minus 1 equal to 0. So if we add 3 to both sides, we get one solution to be 3. Or if we add 1, the other solution is 1. So again, these solutions are really the x-intercepts of the graph, which we see in step 2. So the next thing we want to do is to graph y is equal to x plus. And yes, the 1 and 3 come up as solutions to the equation, or represented as the graph. Now this time, what did we want to solve? Where x squared minus 4x plus 3 was greater than or equal to 0. Well, here we're talking about where is y greater than or equal to 0. Well, we know y is greater than 0 above the x-axis. And we know that y is equal to 0 on the x-axis. So this time we're looking for values of x. Corresponding y values are either above the x-axis or on the x-axis. Well, above the x-axis, notice in region A, y is above the x-axis, and in region C, y is above the x-axis. Well, where is y equal to 0 on the x-axis? Well, that is your x-intercept points. So really the only difference here, those endpoints now are going to be able to be included in your answer. And exactly what I have written here, we're trying to find the regions for which the graph lies on or above the x-axis. And the graph lies on the x-axis at the x values of 1 and 3. And the graph lies above the x-axis in regions A and C. So therefore, those intervals, that is region A's interval and region C's interval, which is -infinity to 1, union 3 to infinity. Notice the brackets are included there because those x-intercepts make that inequality true. Now, I wanted to do one last problem for you, and this is the section 9.2 problem, because 11.8 can be extended to any type of inequality. It doesn't matter what it is. The main thing that's going to be different is how you actually have to solve that associated equation. So here, if we want to solve where absolute value of x minus 5 is less than or equal to 3, the very first thing we do is to solve that equation. Now, this is the one thing from section 9.2 that you need to know how to do. To solve an absolute value equation, you have to isolate the absolute value, which is done here. And then depending on the sign of this number on the right-hand side, you're either going to have 2 solutions, 1 solution, or no solution. If this number is positive, there are 2 solutions, because there are 2 numbers with the same absolute value. That is the positive and the negative value. So I have to set this inner expression, this x minus 5, equal to the 2 numbers whose absolute value is 3. And that is a positive 3 and a -3. And so whenever we add 5 to both sides, we get x is either equal to 8 or x is equal to 2. Then the next thing that you want to do is to graph it. Now, whenever we graph, we have to graph the side that's always opposite from 0. Since this one was not originally given to us in the form of one side with 0, we need to subtract 3 from both sides. So really what we're going to graph is this y is equal to absolute value of x minus 5 minus 3. Now be very careful when you enter that on the calculator. The absolute value expression needs to be contained in parentheses before you type the minus 3. Now to get absolute value, you will need to press your math menu and then arrow to the right to the number menu. And then the very first option you should see is ABS, and that represents absolute value. So you'd want to select absolute value, then type in the x minus 5, close parentheses, and minus 3. Absolute value graphs are always V-shaped. You're going to get more into this in the next course. But for right now, the main thing you need to notice is that those solutions, 2 and 8, were still the x-intercepts of the graph. And also notice that the same thing happens that did in the quadratic problems. Around those x-intercepts, we have 3 regions, A, B, and C. In region A, everything is above the x-axis. In region B, everything is below, and in region C, everything is above. So it does the same thing, either all above or all below. Now, what we would need to do now is to try to solve this problem. We have absolute value of x minus 5 minus 3 is less than or equal to 0. So since we're trying to solve where it is less than or equal to 0, absolute value of x minus 5 minus 3 is less than or equal to 0. Less than or equal to 0 means we want to find where it is below the x-axis, because that's where y is less than 0. But the equals to 0 means where it is on the x-axis. And so the things that would satisfy that for us is region B has points that are below the x-axis, and also those x-intercept points can be included. So our solution to this problem is interval B, but with the endpoints included. And so that's going to be from bracket 2 to 8, close. And I hope this sheds some light for you on how you can use the graphing calculator to come to your answers more quickly. I'll give you a little bit more information on another type of problem at a later time. Thank you.